On December 15th of 1916, a young boy named Maurice Wilkins was born. At age 6, he moved to England due to his father's career in medicine, which likely is what inspired Wilkins to pursue the sciences as well. Wilkins obtained his PhD at Birmingham University, and during World War II, he participated in the Manhattan Project studying uranium isotopes. After the war, he decided to study a less destructive topic, and his focus shifted to the booming study of DNA, which he worked on at King's College. Here, he began his work using X-ray crystallography. He made great headway isolating single strands of DNA for study, and was well into his research when he was told that he was being sent an assistant. However, there had been a bit of a miscommunication. The woman being sent was not his assistant. Rosalind Franklin, an expert crystallographer, was to be his partner. Born on July 25, 1920 to an Ashkenazi Jewish family in England, Rosalind led a very fulfilling childhood. Her father, Ellis Franklin, was heavily involved in a college for working men, and her mother was on the education board. And to top it all off, Rosalind herself was an exceptionally brilliant child and exceptionally driven. She was at the top of most of her classes at St. Paul's Girls' School, and she played several sports competitively, such as croquet and hockey. She was known to love her family's vacations, in which she developed a love for adventure which continued into her adulthood. Rosalind was attending Cambridge University when World War II broke out. She wanted to continue her studies, but as a Jewish woman during the most infamous act of anti-Semitism to ever plague this earth, she faced quite a lot of pressure from her family to devote herself to the war effort entirely. Eventually, though, she found an outlet for something that she could do for the war in the form of crystallography. Rosalind learned to use X-ray diffraction to photograph incredibly small samples. She used this to study coal, and even went to France post-war to continue her studies. But eventually, she had to return to England, where she was able to secure a position at King's University as a partner to Maurice Wilkins and as a supervisor to the doctorate student Raymond Gosling. It immediately became apparent that Rosalind and Wilkins didn't get along very well, so they ended up agreeing to split their research. Rosalind had previously discovered that DNA could take on two forms, which she dubbed A and B. The A form was shorter, drier, and appeared crystalline. Most importantly, it could be reproduced at will. The B form, on the other hand, was long and thin, a result of being hydrated. It was considered paracrystalline. Rosalind set out to study the A form of DNA, and Wilkins the B form. However, they had a problem. In order to photograph DNA with X-ray diffraction, it had to be pulled out into long, thin strands. From there, it could be isolated and worked with. In Rosalind's case, it would be strung up and photographed at 15 millimeters. The photographs worked because the X-rays would bounce off of the molecules on the DNA due to their high molecular weight. This created dark and light spots. The higher the molecular weight of the DNA, the better. This is why Wilkins was upset when he found out that he had been stuck with only the low molecular pig thymus DNA, while Rosalind had taken all of the Signer DNA. The Signer DNA, prepared by Rudolf Signer, had a very high molecular weight, which nobody had quite been able to replicate at that point. And, as stated earlier, Wilkins did not have the Signer DNA. Wilkins had the pig thymus DNA, which, to make matters worse, he was having trouble crystallizing. But that's enough about Wilkins for now. In the meanwhile, Rosalind was having a blast with the Signer DNA. She determined that the phosphates on DNA were on the outside, hydrophilically soaking up the water. This is how the DNA lengthened. She was also able to take X-ray photos of the DNA strands in both A and B forms. The photographs were incredibly tedious to obtain, with her famous Photo 51 taking 62 hours to capture. It was around this time that Watson and Crick showed up at the college, intent on solving the structure of DNA. Rosalind was open to their idea of DNA being a helix, but felt that they shouldn't jump to conclusions without first doing the proper research. Safe to say, Rosalind didn't get along too well with Watson and Crick. On May 1st to May 2nd of 1952, Rosalind took a photograph of a strand of DNA. It was very crisp and very clear, and it showed a distinct X in the center. Rosalind named it Photo 51. One thing to note here, however, was that Photo 51 was of the B form of DNA, which Rosalind had promised to leave to Wilkins while she studied the A form. So, out of respect for her coworker, Rosalind set aside the breakthrough for later and resumed her study of the A form. In the meantime, Wilkins was getting along with Watson and Crick and strongly supported their proposed models of DNA. However, the fact stood that none of them had any way to prove their legitimacy. They were thrown a landline, though, when Gosling mentioned to Wilkins that Rosalind had captured an excellent B photograph and offered to show it to Wilkins, the B researcher. To be clear, Gosling was not in the wrong for showing Wilkins the photograph. This was Gosling's thesis after all. It would have been completely normal for him to show the progress on his thesis to the supervisor of the lab. It was Wilkins's responsibility not to, as a random example, leak the unpublished and uncredited research to two researchers from another university. So Wilkins was shown Photo 51, and then Wilkins showed it to Watson, and then Watson sketched it out to Crick. And they used the data from the photograph as well as some numbers from Wilkins to construct the first accurate model of DNA. Don't worry too much about the details on this for now, there are going to be 3 entire presentations on it. Shortly after this all occurred, Rosalind left King's completely unaware that her research had ever been stolen. She spent the rest of her life studying viruses at Birkbeck College, where she happily worked alongside trusted colleagues. Tragically, Rosalind died of ovarian cancer at the age of 37 on April 16, 1958. She left behind many loved ones and a powerful impact on our understanding of the structure of DNA. Wilkins continued to work on DNA and died at age 88 on October 5, 2004.